You don't really. It looks good though. I can see the whole slide.
Yeah. Okay. How do you schedule it? Fit. All right. Well, anyway, so yeah, my name is Josh Long. That's my email, josh.long@springsource.com. Please don't hesitate to reach out to me. I'm always happy to answer questions. As I mentioned, Craig Walls is on the line. All right, moving on. So why are we here? This is very important. We have certainly done a lot of great talks about Spring and support for REST in the core Spring MVC framework, and we've seen individual talks talk about some of the other frameworks that build on top of that. But what I wanted to convey to you guys was the sense that we have a very, very comprehensive sort of full stack, right? A lot of people don't know that beyond Spring MVC, we have other projects that complement Spring MVC and that allow you to build much more sophisticated, much more powerful RESTful APIs. So we're going to take a look at that today. We're going to actually look at it in terms of core REST, and then we're going to build a more sophisticated application out of that. Just a quick bit of rehash. REST, of course, is an architectural constraint based on HTTP, originally proffered by Roy Fielding in his doctoral dissertation in 2000. The constraint embraces HTTP, as you might imagine, given Roy Fielding's position on the HTTP 1.1 spec. It's a style, not so much a standard, so there are no hard and fast rules. You will see that there's a lot of pragmatism that needs to be applied when using REST. It's not about dogmatic religious fervor and guidelines and so on. One great way of looking at REST and the sophistication of REST APIs is the Richardson maturity model. This is a model developed by, this is a model that lets you describe APIs in terms of how well they comply with the REST constraint. The best explanation I've ever seen for the Richardson maturity model came from Martin and Fowler, and the link is at the bottom there. At the very bottom level of the maturity model, you have the swamp of POCs. In this model, you have something that is most decidedly not RESTful. Okay, it's typically things like SOAP or XMRPC, wherein you have a single HTTP endpoint that basically acts just as a tunnel. I mean, they're just using HTTP as a channel or a conduit through which to send RPC calls. This is not exactly RESTful. In fact, this is the opposite of RESTful, and people need to see this first before they can sort of embrace a better alternative with REST. Typically, these kinds of services, SOAP and XMRPC, for example, channel everything through one HTTP verb and ignore all the native properties of the underlying HTTP platform. At level 1, we have a slightly better situation. We have the, in this model, we distinguish among nouns. We distinguish from nouns. So instead of just having one HTTP endpoint to which everything is transferred, you at least use URIs to sort of subdivide and distinguish individual nouns or entities in the application. But really, this is still very much the level 0. It's just slightly better trappings. Okay, we don't want this model. We don't want this level either. This is to be avoided if at all possible. Level 2 is where a lot of people start. This is where if you use Spring MVC support for REST today, just using it out of the box, this is the level you get dumped in right there. At level 2, HTTP verbs. This is where you're actually leveraging transport native properties of HTTP. You're taking advantage of idioms native to HTTP, like status codes and headers and so on, to build an API that's expressive and idiomatic. Okay, in the same way that people in the Python community talk about Pythonic API implementations, you might talk about a RESTful API implementation. Quick rehash, of course, HTTP verbs refer to the various verbs supported inside of HTTP, of which I've listed only 4 here. There are, I think, at least 3 others. These verbs are ways to signal to the server that a resource at a given URI should be mutated. What that, and they usually have common meanings, but of course you have to map that meaning to your individual application. The mutations that you can expect of these resources map typically to the sort of mutations you would typically do to data entities in your domain model. So it's very convenient. A lot of people try, and you can with some approximation, map these 4 verbs to CRUD, but there's some nuance. So get is going to be used to retrieve the resource represented by a URI. This means that, when you go to a browser and you enter a URL, you're given a response. That's a GET request. Delete, of course, signals to the server that the resource represented by the URI should be deleted or removed or hidden or whatever that means to your application. Post is typically used for creation, but it can be used for update. The semantics are a little different. Typically, when you post to a collection endpoint, for example, users, and then you create some sort of resource, and you create a new URI for that resource. That resource, that the URI where that resource lives is returned back to the client in the location header. So people who use post and post against /users will expect a location header signaling that the new user lives at users /22, for example. Put, on the other hand, is typically used for update. It says, I have a URI, it already exists, it already has an ID, it's a unique resource. I want to update it, right? So this is what you use for replacement. One thing people often point out is that if you're trying to do REST from the browser, there is no support for delete or put or any of the other verbs except for HTTP GET and POST. Spring provides the hidden HTTP method filter that you can use. And so if you're doing AJAX and you want to send a call from the browser to the server, you can send a request parameter called _method, and in that parameter you specify the verb that you would like to apply, and Spring MVC will automatically route the call to the appropriate handler that handles the verb. So if I post to an endpoint and I say _method equals delete, even though I'm posting from AJAX, Spring MVC will route it to the delete controller. In this way, all of your verbs, all of your API is visible and usable from the browser. Status codes are a way of conveying metadata about the request or the response. Status codes signal what has happened in response to that request. There are certain categories of status codes. They're numbered, right? So we all know about the very, very famous 404 error, page not found. That's one type of status code. There are other such status codes in the 400 series, so 400 to 500, 404 being the most famous. 200, if you get a 200, is success. That means everything's A-OK, and that's what Spring MVC will return by default, barring any exceptions or any other status codes that you specifically provide back. When you go to a browser and you open up a URL and you do a request, you don't see it, but when that page is loaded, at some point you must have gotten an HTTP 200. Okay, so let's take a look at a very, very basic RESTful application. This is sort of the entry level. You've just started with Spring MVC and you want to build a RESTful application sort of scenario. Okay, this is what we typically talk about. I am looking at code, and you guys can please feel free to follow along at home. The code is available on github.com/Josh Long /the Spring REST Stack. Okay. So I'll go to the REST project here. I've got a very simple domain. This is like the simplest of all domains. It's just users, and then users have a one-to-end mapping of customers. So this is and behind the scenes I'm using Hibernate, but that is utterly, it's insignificant and irrelevant to what we're trying to do with REST. It could be any kind of service, or it could just be DTO, it doesn't matter. Those are the types that we're working with for this application, however. We're going to evolve the application from here. So, okay, here's a typical Spring MVC application, and this is level 2. Like I said, in the maturity model, this gets you a long way. So first thing first, I'm using a web application initializer, Spring MVC and Servlet 3.0 used in conjunction makes for a very fine pair, and you can very easily configure web applications without a web.xml or without any Spring XML. I'm using Spring MVC's abstract annotation config dispatcher servlet initializer. This is kind of a combination class. It's a class that will set up a Servlet 3 application initializer and bootstrap it using Spring 3.0 or better Java configuration classes. So it does everything for you. So here I'm going to specify that I want my services configuration class to be imported. I want all the data sources and transaction management and all that stuff to be imported, and then I want my web application and the configuration therein to be brought in as well. So this is the servlet config if you can imagine a typical web.xml, you would put this guy in your context loader listener, and you put this guy under your dispatcher servlet, right? So it's a tiered application context hierarchy. I've registered a few filters here, including the aforementioned hidden HTTP method filter, and I've registered a multi-part filter to handle file uploads, okay? I'm using a Servlet 3 environment, Tomcat 7 in particular, and Servlet 3 takes it, it offers a lot of features, including a native inbuilt file upload facility, okay? So to configure that, however, I have to customize the registration. So I've overridden this method, and I'm going to tailor the servlet registration for Spring MVC, the dispatcher servlet. What I'm saying is I want to build a multi-part config element, and I'm telling the multi-part config element which directory to store any files that are uploaded, and I'm telling it how much, how large the maximum sized file upload can be, and so on. And then when we get down here, I have a typical Spring MVC configuration class. For those of you who haven't seen this is just like a Spring XML file. In terms of Spring, when Spring sees an annotation at configuration on the class, it instantiates the class and then invokes every method that it sees that's annotated with @bean. The return value is what's stored in the context. So you can read this method, this arrangement right here, you can read this as being a bean whose ID is the method name, so multi-part resolver, and the class type is the return value. And if you would do that in XML, that's exactly what you get. I've turned on component scanning. This is more like context::component scan in the Spring MVC in the Spring XML world. And then I'm turning on Spring MVC itself. This is a MVC: annotation driven in the XML world. This annotation buys you a lot. It's based very obviously on convention. There's a lot of parts of it that are based on convention. So if for example I have a JSR 303 implementation like Hibernate Validator on the class path, then Spring MVC will automatically support validation and bean validation for you for requests and forms. If I have a Commons file upload or a Servlet 3 API for file uploads, it'll automatically support multi-part file uploads in requests. You don't have to do anything more than register the multi-part filter. If I have JAXB or JAXON, these are two different libraries. One is for XML to object marshalling, and the other one is for JSON to object marshalling. Then Spring MVC will have native support for delivering responses that have been converted to JSON or JAXON. It does a lot of these things. I mean, there's a lot of power there. The only thing I needed to do is to register my resolver here. This resolver, I need to tell Spring MVC that I want to use the standard Servlet 3 multi-part resolver as opposed to the Commons file upload one. That corresponds to this multi-part filter up here and the registration up here. Okay. And then once we've done that, I've actually just got a couple of controllers. These are Spring MVC controllers that I can use to manipulate my domain model, right? These are RESTful controllers. If you've seen Spring MVC before, then this will look very natural. This is the same kind of API and same sort of approach that you would take if you're building a web application, serving HTML pages and so on. So it's a controller class. I've told it that I wanted to handle all requests going to /users, okay? And I'm using the API. I'm using final constant strings to be able to avoid magic strings hard-coded in my annotations everywhere. I take advantage of the fact that Spring has good dependency injection. I inject a service, I can use that, and then I go about the sort of procedural business of setting up my endpoints, right? I have one endpoint that'll handle all HTTP delete requests for the users, for the URL users/user ID. So it's users/ and then some number. When Spring MVC sees that number, it'll extract it. It knows to extract it because the URL string itself has curly bracket, user curly bracket. And Spring MVC will see that and it extracts it as a path variable and makes it available to you for inspection in the argument, which is by having a variable named user as well. So user, right? So the idea is I've got a service, I'm deleting my user from the service using whatever backend technology I'm using. In this case, it's Hibernate in JPA. And then I return the user data. Right? I actually return the data back from the server. Here I have an HTTP GET endpoint. Again, same URL, so I'm going to go to users/user ID, passing in the ID, and that ID will be passed to me in my argument. And then I have a user object, and I have an annotation @response body. the at-response body signals to SpringMVT that the return value from the SpringMVT controller should be converted into some sort of representation that the client can work with, like JSON or JSON. And I've got a few others here. We've got an endpoint users/ID/customers. This will load all the customer records that are being managed by a given user. Here I'm simply creating an array list. This is a specific subclass of array list typed to customers so that I can retain the generic metadata. It gets baked in if you create a subclass, but it doesn't get baked in if you just return an anonymous instance. And then I'm going to load all my customers, and I return that information. When the client gets this, it'll look like a JSON representation of a collection. So bracket and then object, comma, object, comma, object, comma. What else? Oh, I've got a URL here for loading a single user, so a single customer rather. So it's users/ID/customers/ right? So and then ID. So it's two IDs here that I need. I need the user ID and then the customer ID. And then given that information, I can find a specific one. In theory, I should be using the user ID to validate that this is the correct, that this is the correct mapping, but I'm not in this particular case. And that's pretty typical. I mean, we've seen a lot of this kind of stuff before. I think you could agree this is all fairly procedural. There's not a lot of interesting stuff happening here. I have another controller here called the user profile photo controller. This one handles updating and retrieving my, a profile photo for the user. Okay, this is what it's using that file upload support in SpringMVT that we configured earlier. So here I've got an endpoint. The endpoint is users/user ID/photo. So this will give me access to the bytes, and it'll let me manipulate the bytes representing my photo. So if I post to that endpoint, passing in the ID, I can get the user, and I say I have a request parameter of type multipart file. This multipart file is just a wrapper around the data coming in from the Servlet 3, multimedia API, the multipart API. So here, I use the multipart file. I grab the input stream, copy it to a collection of bytes, and then I send those bytes as well as the media type from the content type that I've obtained from the file to a service, which stores it in this case rather naively on the file system. But you could imagine putting it on a SAN or MongoDB, GridFS, or some other resource where you keep your images. Once that's done, I construct a response. I set up some headers. Right? I set up this is actually a subclass of something called the multi-value map. So we have strings to n objects, right? It's a string of it's a map of string to n, collection. And then I build a URL telling the user where the photo is, just to be proper. In this case, there's no real value in doing that because the URL is the same, but I do that to show you how. So here I'm building a URL, and notice that this is fairly type safe. I don't have a lot of string mending and a lot of stuff happening here. I'm taking the current request, and I'm using that to bootstrap the creation of the new URL, and then I add to it by adding a path segment. In this case, the users/user/photo, and I'm asking the component builder, the URI component builder, to expand the path variable for user and plug in the value that we obtain in the request. The request value is 21 perhaps, and that'll be the value that's shown here. I set that URI as the location in my HTTP headers. I construct something called a response entity, which is a subclass of HTTP entity, passing in the headers and passing in the status code. If this were a response where I wanted to deliver the payload itself, I could do that as well. It is fair practice to return a payload representation of something you've posted. However, in this case, since we've updated an image, we don't want them to get the payload representation. We don't want to make them download the image they just uploaded, right? That would be very inefficient. Can you imagine doing that for a YouTube video or something like that? You wouldn't want to upload a 70 gig video and then have to re-download it just because it's good REST practice to show the representation. So in this case, we just return a location header telling them where they can obtain the resource later on. We don't bother to retransmit the payload. The get method is fairly similar. It's an endpoint that'll take a user ID. We use that to read the profile photo from the service. The profile photo is just a local type that I'm using to wrap both the bytes as well as the media type for that photo. and I use that information to set up the HTTP headers, set the content type, and then return a response entity that contains the photo, the headers, and its status code. In this case, HTTP status OK. So, save that, sure. We can run this code now. I'm going to go ahead and deploy this application to Tomcat. We'll take a look at it a little bit. Let's see. So, I'll go to my browser here. Localhost 21. Oops. So you can see I've actually got, this is just data coming back from my database. It's a JSON structure here. Pretty easy to grasp. I mean, it's fine. We understand what's going on here. If I go to users 21 photo, you can see I got the SpringSource dog, this dog that has been hanging out in my SpringSource beanbag here as my profile photo. And that's about it. I mean, I can go ahead and change all this stuff. So, for example, if I were to open up the file upload thingy, this is a standard HTTP HTML form, and I can modify it here. I'm going to go ahead and modify it here to use REST. And you can see there's nothing fancy. It's just a regular form. It's multi-part form encoded. I'm posting to the URL for the photo, and I've got a argument, a request parameter called file. It's an input object, and it will send the multi-part data for me on our behalf. I can choose a new file. In this case, I'll choose the standing version of our SpringSource dog here. Submit. Oops. It's wrong URL. Go back. Refresh. View page saves. Yeah, that'll be fine. Choose this guy here. And if I go back to our URL and I refresh, you can see he's now it's a different profile photo. So okay, simple API, very fine. That's what a lot of people are very used to. It's very natural development API like that. But there's some problems with this approach. Okay, the first of which is that we don't really know where to go unless we know the URLs. That relies entirely on me having written documentation and you having read it, if I had written it, that is, if I have written it. And also, the URLs, they're subject to change. I'd like to be able to move my API without clients breaking each time they use it. So to support this sort of use case, to support decoupling the API from the URLs, we have something called hypermedia. This hypermedia is best espoused in a book called Rest in Practice by Jim Weber. It's a design pattern, if you will, for HTTP applications. On the Richardson maturity model scale, this is called level 3. This is the top of the stack. There's a long, unpronounceable acronym called HATEOAS, or HATEOAS, or hypertext is the engine of application state. The idea here is that you return context, you return a little bit of metadata with the response, telling the user where he or she can go next. Okay, these are conveyed to the user in terms of links. Links describe a URL and then the relevance of that URL. So href and then rel, right? The relevance of that URL in this case, for example, is that I can get the information about customers under the user. So if I make a request to, if I make a request to users/232, I would be given this link showing me that if I followed the customer's URL, I can also get the customer's data. Yes, it's fairly easy to glom, to parse what I'm showing you here. It's fairly easy to see that if I go to this URL, I'll get the customer data. But the nice thing is the client doesn't need to know that. They just need to know that if they look at the customer's link, they'll be given a URL. And so this URL can change entirely between revisions, and the client won't be broken. Your rel becomes the contract. That's the piece that they are supposed to work with. Hold on. Okay. Okay. So let's see here. So now let's take a look at a project that supports these kinds of applications called Spring HATEOAS. Sorry. Okay, cool. So let's take a look at Spring HATEOAS. I have a HATEOAS compliant version of this application. This is slightly different. The profile photo controller stays the same, but we've redone the user controller quite a bit. So while we're doing this, I'll go ahead and relaunch the user controller. Remove this one. I'll relaunch the project, this time using the more evolved version. Okay. Okay, so the code here is slightly different. It's still Spring MVC. It's still very much what we expected from before. It's a controller, and I still have URLs, but the important bit is that the URLs are no longer what the client considers a contract. That's not the API that they're going to work with, right? The idea behind HeyDOS is that it makes it very easy to return these links, and the way you do that is you create something called a resource, a Spring HeyDOS resource. The resource itself contains a payload, so that's you still send back the object that you're going to work with, but you also send back this wrapper resource envelope, if you will. The resource envelope contains both the payload as well as any links, and you tend to do this kind of thing quite a bit. So there's a pattern in Spring HeyDOS to kind of codify the recipe for creating these resources. You create something called a resource assembler, and that's what I've injected up here. I've created 2 different resource assemblers, one for users, one for customers. And these resource assemblers handle the chore of creating the links and all that stuff for me, given an object. So I'm implementing resource assembler from user to resource of user. Okay, this is a converter or an adapter, if you will. I have one method, resource user to resource given the user, right? And all I'm doing is I'm doing a copy constructor. I'm nulling out the password so that the REST response doesn't have the password. I'm grabbing the ID, building up my resource, and I'm building links, okay? These links are navigation points, right? These are places where the user can go after they've been given this record. You should note that I can do things dynamically here, right? If my customer has a certain state, I want to respect that state, and perhaps there are certain operations that shouldn't be available to that user given that state, I can selectively include or exclude these links. They don't need to be there. The links themselves are using a Fluid API, a DSL, based on static imports from the controller link builder object. And I'm using kind of a Mockito mock API here. What this does is it says, I want to build a link to this method on the user controller class, right? So that's the controller that we had before. And I want to link to the URL that will invoke this method. This is pretty slick. This is kind of like what it's doing is it's creating a proxy and then it's trapping the method invocation. It doesn't actually call the method. It just needs the API. And this is a very good example of DRY, right? I don't want to have to do string manipulation. I don't want to have to remember all the URLs and so on in my link building code. So instead, I let Spring MVC look at the method and then look at the request mapping information on the method and then grab that for me. So when Spring MVC in Spring HeyDOS builds the link for me to my self reference, right? A link that simply points to myself. That's a link that a client can look at and keep for a small amount of time if they need. There's a convenience to do that, right? I can just say link to the user controller, load user by ID. And since I'm using the path variable, I pass in the ID. I actually need that, right? Because that forms part of the API. That forms part of the URL. But if there are other methods in your Spring MVC controller, you can ignore those. You can just pass in null because Spring HeyDOS doesn't need the rest of those arguments. It just needs the ones that contribute to the definition of the URL. I've built up other links as well. I've got one for customers, right? So this is the customers rel, and I've got another one for the photo, right? The user profile photo. So it's a photo rel. That gets sent back. I add that to the resource, and then I return that. And then in my controller, wherever I'm using a user, I use that resource assembler to build my response. So here I'm saying, go ahead and give me a user resource for the user that I've just removed, create a response entity with a payload of type resource, which has a payload of type user. And I'm sitting back in HTTP status OK. The rest of this was pretty similar, and it's the same as what we saw before. You can see here I'm loading all the customers, all the customer data. So here I'm actually creating a collection of type resource of type customer. And then you can see I'm doing the sort of procedural bits of creating all that stuff for the response. I've also created a link for the collection itself. I'm not creating a link for each of the individual entities. I'm doing that inside the resources resource assemblers, but I'm creating a link for the collection itself, the collection of customers. And so on. So okay, let's take a look at that in practice here. This is running in the background now. So if I go to this URL, it's now at HeyOS, of course. So the same APIs still work, of course, but the nice thing about it is it doesn't need to work, right? I can actually change bits in the background. So users, 21. So you can see I've got now a slightly more interesting payload here. I've got a JSON representation of an object that has a property called links, and then the links property simply has a collection of links. These are the links that we sent back. Remember, these are the same kinds of links that you see in CSS, in HTML whenever you set up a CSS link. When you do link rel equals whatever, text CSS whatever, and then you have a reference to the CSS style sheet. That's the same thing. It's a standard construct that you use all the time in HTML. It happens to be generically useful as a way of conveying links for APIs as well. And if you were going to send back an XML representation of this API, it would indeed look exactly like you would have it in HTML. So I can see here I've got a self link. This is the common case for conveying my own identity URL. So HTTP HeyOS users 21. I've got a customers URL. So here if I go to this URL here, I can actually get all the customer data back. And again, same thing. I have links inside of this, and I have content, and the content has all the all the individual entities, and the individual entities have links themselves as well. I have a photo URL, which you saw, and I have the actual data itself kind of local to the payload. So the client gets everything they need and more, right? And you can actually do some very, very smart things with this. You can actually go to something like the Spring REST shell, for example. Spring REST shell. And then I can navigate using the Spring REST shell to the endpoint. I can say follow users 21 discover. Oops. Follow users. Yep. Follow 21. Yep. Oh, sorry. I'm doing it relative to the wrong URL. I don't know what that was. Up. Follow HeyOS. Follow users. Follow 21. Get. And you can see there's the pretty printed representation of the same resource. I can also do something called discover, and this actually gives me a nice table of the links that have come back in the payload, so I don't actually have to manually inspect this resource here. And this gives me kind of a dispatch table, if you will, of places I can go. If you can imagine like a shopping cart scenario, which is the scenario that's put forth in the REST in Practice book, if I'm in the middle of processing an order, I might have a rel here saying submit order. If I've already paid, however, I might have another rel for refund, or submit a complaint or something, right? So you can do kinds of workflows. Based on these rels, certain actions are available, and they can transit from one to another solely based on these rels. The URLs themselves are irrelevant. So this is fine, but we still end up doing quite a bit of, I would argue, kind of boilerplate code. So because a lot of the code we did in the user controller is solely designed to help you build handle the data access operation. So we're going to go ahead and remove this guy here. Goodbye. And we're going to go ahead and start up the HeyOS data application. And get back to this. So Spring Data REST is a RESTful way of exposing Spring Data repositories for users. If you don't know much about the Spring Data repositories, I highly encourage you to check it out. The crux of the idea is that you can, based on convention, generate queries, right, for your data access tier. We have, bindings for MongoDB, for Neo4j, for JPA, of course, and there's Gemfire as well, and there are third-party bindings for Elasticsearch and Solr and JDBC and lots of Couchbase, I think. I mean, there's just a lot of different implementations out there. We do this based on convention, so you create an interface, and this interface alone and your interface might extend the Spring Data paging and sorting repository. And what this does is it gives you generic finding, CRUD methods facilitating updates to your JPA entity, your user JPA entity. And I've told it the type of the primary key as well. Beg my pardon. I've added a convenience methods here that I want specific to my domain. And so, for example, if I create an interface called user repository and I add a method called find by username, well, you and I can squint at that. We can look at that in our heads, just immediately translate that into a query. Select all from users where username equals user, equals a parameter there. And that's the point. If you and I can squint at a method and kind of guess or divine its sort of representation in the actual underlying data store, then it's probably some stuff that we don't need to be writing. It's probably something that we can let the machine write. And that's exactly what we do here. So, for example, this query does indeed become a JPA query called select you from the user where username equals. If I add another method, find users by first name or last name or username, Spring Data will look at that method name and then extrapolate a query for us. So it becomes select you from user you where u.username equals question mark and u.first name equals question mark and u.last name equals question mark. So it's very conventions oriented. We like that. That's very powerful. The only other thing that's sort of salient is that we've used Spring Data REST at REST resource URL annotation here, and we've told Spring Data REST that we want the stuff to be available as a RESTful repository. Okay, this gives you a lot of power for very little work. So I've deployed the application. Let's take a look at that now. So now, you get a lot first. So first of all, here's the same URL as I had before. I was able to keep, basic standard. It's pretty printed. This is nice. You can see it automatically generates links for us, for certain things. Actually, I have even more than that. I can go to the root now. Now I have collections for everything. You shouldn't, if you don't want it as part of your API, you can disable it, but it's nice to know that's there. I can go to the users collection here, and I can see all the data coming back. That's nice as well. It's even more sophisticated than that. I can actually do paging and sorting because Spring Data itself supports paging and sorting. So page can equal 1 and limit equals 2 and sort equals, I guess I can just do first name, right? So you can see there, I've got only 2 records this time. I have my links and then 1 record and then another record, right? And then I have an extra bit of metadata in the response called a page. And this page tells the client that, I'm sorting by first name, ascending, and then here's the offset and so on. So you can actually build very nice sort of interactive screens. This is, I would argue, not the most RESTful things, but it can be an implementation detail that you keep to yourself, perhaps for driving views on an AJAX screen or something like that. And this is a lot. You get this all for free, right? You don't have to do anything. And in fact, you actually even have those finder methods. So if I actually do the search, let's see. There's a search endpoint there. I guess we'll skip that for now. We don't have enough time. But you can actually call that find by username or whatever. You can actually use the finder endpoint there and use that to drive screens where you say, oh, well, add a first name, add a last name, and then build a query. But don't add this one or whatever. That's very powerful. The code itself is fairly simple. We've removed even more code now to be able to build that. We've removed, for example, the user controller. I don't have that anymore. I have the photo controller, but I don't have the user controller anymore because Spring Data REST will handle that for me. I do still have to build links, right? But we don't have the controllers to link to, right? Before we're using the user controller entity, or the class itself, to create those Mockito-style links. So I've created a user links class, and the links is simply a place where I've kept the recipe for creating links to myself. And I'm using a different version of the link builder that we saw before. This time I'm using an entity links. The entity links looks at the metadata on top of other classes if you have it, and it looks at Spring Data REST repositories, and it, based on convention, builds up URLs for you. So here I'm saying entity links, give me a link to a single specific resource, in this case a type of user class, with the ID coming in from the user object there, and then make that a self-rel, right? Same thing for a customer's link and a photo link. And I'll use that, the only place I use that is in the event handler. This is a Spring Data REST concept it's a callback class called a repository event handler that'll be called whenever customer data gets manipulated. And I have callbacks of various names. Right? The annotations are what trigger the connection. So here I've got a handle before create callback that gets called before Spring Data REST passes your customer JPA entity to the repository to be persisted. And I can do things like validate the state. For example, I might do validation here, saying, hey, if the customer has first name and it has last name and it has a valid user, set up the sign-up date because we need that, right? And then persist, or return, and Spring Data REST will persist it for us. I can also do things like auditing. I can handle those kinds of concerns here as well. So, for example, after the Spring Data REST repository has persisted it, this method gets called. After it's been deleted, this method gets called. So that's a lot of power. I would argue that's we've gotten rid of code and we've actually got a simple API to boot. And that's a very, very nice thing. Of course, the photo controller is still there because we can't get rid of that. Spring Data REST doesn't know what to do with file uploads and so on. But that's still less work for more, more value for less work. Okay. Oops. So another common question, of course, is how do we handle security in this brave new RESTful world? Security can be what you need it to be, right? If you have a trusted client, and by that I mean a client that can keep a secret, like an Android application delivered over a marketplace, where the binary itself is as immune to tampering as possible, or maybe you have an Android application with or an iPhone application or iPad application, where you keep the password, but you also have it digested. That's fine. I heartily recommend you use TLS if at a minimum, and then perhaps use BASIC as well. And this works. If you just want to connect one well-known client to one well-known service, this is just fine, right? So you don't need anything more than the standard HTTP facilities that are available to you. However, as often as not, we need more than that, right? As often as not, we want multiple clients to be able to consume our API. That's the whole point. A lot of times you want to stand up an API on the open web, and you want to be able to let one-to-n clients consume that API. Well, you can't share a password with all of them, and even if you could, there's another wrinkle. What if you have a user context? You see this a lot in situations where, like for example, with Facebook. Facebook owns you own your profile data, and it's stored on Facebook servers. If you want to let a Facebook app that you install on your iPhone or on your maybe you install a Facebook plugin like Farmville, or you install a Facebook app that you work with on Android, you don't want those clients that may or may not have been written by some trustworthy third party. You don't want those clients to have your password. Even if you did trust them, if they have your password and you change your password, then you break all those clients. So what you need is a way to decouple the authorization from the password, right? And you need a way to do that so that end clients can consume, those APIs. For this, we have something called OAuth. OAuth, I'm not going to lie to you, is fairly complex. So it's a good thing that Spring has two great projects that hide or simplify most of it for you. On the server side, by the way, this is the sort of a canonical example. You have a Facebook application and you want to approve it, right? So let's look at the actual OAuth stance here. This is a situation where I have a Facebook application, and the application itself, I want to install it, and I want to make it available for my inside of Facebook. The application redirects me to Facebook, which prompts me to log in, and then finally I'm prompted to give it permission. I give the application permission, and then that application has the ability to do what it needs to with my information from Facebook. This is an example of Facebook having secured their API with OAuth, and you can do the same thing using something called Spring Security OAuth. So in this scenario, you are Facebook. You have your own RESTful API, and you want other clients to be able to consume that API. To support this use case, you have Spring Security OAuth. Spring Security OAuth builds on top of the Spring Security facilities that are, that we know about, and adds support for OAuth. Okay, so let's take a look at that. Here I'm adding an OAuth client, or an OAuth version of the API, right? This is a different version of the API. Debugging, restart it. So the code here is fairly true to form. We've added a few things to our applications to support the OAuth use case. as you can imagine, we need a sign-in form, right? Because users need to be able to sign in before they can give approval to a client to access the API. And then also they need a page where they can be prompted to approve, right? That's the whole point. You need a page where it says, do you approve this app to use your data on your behalf? We had to install a few endpoints to support the OAuth confirmation. This is literally boilerplate code. You can just take this class exactly as I have it here, put it in the application, and you're done. And we've also registered a few controllers. These are empty at the moment, but they could have just as easily been done inside of the configuration class. And so they're basically just mappings of URLs to JSP views. Okay, so I've got 3 different views here. I've got a sign-in view and an HTML access confirmation view. These are not RESTful. These are just HTML pages to be presented to the user on his behalf. So if you go to the web app folder, webin, CRM, you can see we've got a sign-in form. The sign-in form is just standard, Spring Security type of sign-in form where we have an endpoint that Spring Security installs called Spring Security Check, which expects 2 parameters, username and password. And that's that. Let's see. Hold on one second. Okay. So this is standard Spring Security, and we can use that to create a sign-in form. So let's go ahead and sign in first. We need that now. So here's our revised API. To go to OAuth, you can see I can't get anything. There's nothing there. I'm building this code, by the way, is a superset of the Spring Data REST and HADOS enabled version that we just looked at, but it's now locked down. I can't get in by default. So now I need to go to crm/signin.html, right? And this is going to let me sign in. I'm going to sign in as a user, as the user that we see in my database here, the same user account that I saw before. Okay, yeah, I'm seeing messages and I'm trying to figure out what's going on. Okay, so I'm going to sign in here, as you know, and voila, once authenticated, I'm deposited into my application, and now I can actually interrogate the information in the system, just like I did before, so, etc. But that wasn't available to me otherwise. Once I'm signed in now, a client can make a request and request permission to use that API. An OAuth client can sign in and ask for permission to use the API on my behalf. So let's go ahead and look at that. One last thing I wanted to show you before we move on to that is the security configuration itself. Right now I have the configuration done using the Spring Security XML namespace. It is worth noting that at the time of this writing there's a very, very nice Java configuration centric alternative to this that is inside of Rob, Spring Security lead Rob Winch's GitHub account. It's coming along quite nicely, so perhaps in the next time we do this talk, we'll have a version of that in Java configuration. Basically, we have an authentication manager that delegates to a user service. This is pretty standard Spring Security. The user service simply adapts the responsibilities of Spring Security to your backend system, whether that is if you have LDAP or Active Directory or your own JPA thing, as we do here, then you can provide an implementation of the user detail service, and then Spring Security will use that to check for what are called client details. So each time, if I want the client details for Josh Long, I can use the service to look up the client details. The client details in this case is just an interface, and I've created an implementation that simply wraps users in my system, okay? The configuration itself, I've secured everything except for this URL. So by default, everything is locked down except for the sign-in form. If you want to use anything else, you have to go through the user service, and you have to authenticate. That's what we did with that sign-in form, okay? We have a filter in the processing chain. This filter is provided by Spring Security OAuth. We define it down here. That filter checks all requests and looks for an OAuth request in there as well. If it's there, it'll handle it and do the right thing. Spring Security OAuth knows what clients to look for. That is, it knows that there's an Android app, it might be an iPhone app, it might be an iPad app, who knows. But you can enumerate those one to end, using stanzas that will look like this. So here I'm saying I need read and write scope, because Spring Security gives you the ability to delineate scopes. I need certain types of grants, and I need resources to be protected. I need the resource name to be called CRM. and I need a secret. Remember, this won't work in all environments. I can't keep this secret. This is a secret that the client has to be able to relate to me in a confidential manner. And if I'm in an HTML page, well, of course, anybody can view source. So this is not a secret that I can afford to keep in an HTML5 application. So in this case, I would create a separate client and perhaps just use the implicit flow, not the password or authorization code, and I'd get rid of the secret here. Okay, so let's look at that. So the application is now secured, and you can see that I've had to log in. I haven't shown you the actual OAuth flow just yet because we need to look at one more very important piece, Spring Social. We need a client. We need a way of consuming the OAuth services. And again, I'm not going to lie to you, OAuth is just a real, it is just a terrible, terrible, horrible API to work with. I would never wish it on my worst enemy. But it is sort of the de facto standard out there, and you need a way to do it. And thankfully, Spring Social makes it just dead simple. I mean, it makes it so simple that there's no reason not to use it. So Spring Social provides an authentication and authorization API for consuming OAuth secured services. It doesn't matter if that's OAuth 1.0, 1.0a, or 2.0. There are bindings for lots of different APIs on top of that core OAuth authentication and authorization mechanism. So these are type-safe APIs that consume APIs provided by other service providers like GitHub or Tripit or Twitter or Facebook or LinkedIn or what have you. If Spring Source itself doesn't have a binding that you want, if you go to github.com/Spring Source and you don't see the Spring-Social-asterisk binding that you want, you might check this wiki page that I have pictured here. This is github.com/Spring Source /Spring Social /wiki/API providers. This enumerates sort of all the known wiki providers for all the known Spring Social bindings from the community for other services like SoundCloud or Flickr or Bitbucket or whatever, right? So there's lots of bindings that the community has provided beyond just this. And for our application, we're going to create a binding as well. We're going to create a CRM binding so we can consume our OAuth secured service from Spring Social. Once you have this, you can use Spring Social in an Android application using Spring Android. You can use it in a web application. It's actually that's the 80% case, I would imagine. That's the easiest case. You can use it any way you like, right? There's a lot of good examples. So let's go ahead and take a look at how I've developed a little client here. This is a Spring Social client. Spring Social provides lots and lots of great batteries included, if you will. It's got all the facilities you need to handle all the OAuth stuff, the whole OAuth dance, and all you got to do is teach Spring Social about the specifics of your API, where to connect and what URLs to connect to and all that. So here I've got a client library. So this is a client module. This is a module that you would ship independent of the types on the server. There's no relation to that. That's why I've duplicated my user and customer and profile photo types, because these are client-side representations. They might actually be different altogether. I might even just have, one combined aggregate object or a user with a profile photo embedded, for example. That's the nice thing about this. Fundamentally, what you're doing is you're creating a couple of implementations that Spring Social needs to understand what your API looks like. One of them is called an API adapter. This just provides your API-specific version of certain common responsibilities that all API implementations need to support. One thing it needs to support is the ability to answer the question, hey, are you alive? Is everything all right? Are things working? In this case, the simplest way for me to answer that question is to say, when I ask my API for the current user, does it return null? If it doesn't, then things are all right. Another thing I want is to be able to create a user profile object. And so to do that, I need to set up certain values that the system needs. So here I'm setting my provider user ID, and I'm setting my display name. This is the display name. In this case, is Josh Long, the one I logged into on the application. I need to be able to return a user profile in this case. So given an instance of my API binding, go ahead and set up a user profile builder. Use that to fluidly build up my API and then return an instance of that. And then also optionally, I need to support update status. On Twitter, this means tweeting. On Facebook, this means posting to the wall. On LinkedIn, this might mean posting to your LinkedIn profile. It's whatever it's a common thing to do, and it's common enough that it's worth having it in one place. In our case, we don't have a notion of updating a status, but if we did, we would do that here. And then all of this is fed into we have a connection factory. The connection factory knows how to create OAuth connections, and we have to tell it a little bit about what kind of resource we're talking to, and we need to tell it about which API adapter and which service provider to use. The service provider is it actually extends the abstract OAuth to service provider, and it's basically it's where Spring Social figures out what API the client needs. And the API in this case is our CRM operations. It's an interface, very much in the style of the Facebook operations or the Twitter operations that Spring Social provides for those relevant projects. We have an implementation of that called the CRM template, and that template needs an access token to do its work, right? So at the end of the OAuth dance, I'm given back an access token, and that access token has to be retransmitted on every request. So I keep that in my template, and my template itself simply extends abstract OAuth to binding, and it gives me, this gives me a lot of convenient things, including a pre-built REST template that is already going to do the right thing. It'll correctly convey the access token along with every request and do all that stuff for me. So by the time I get to this, by the time I start making calls in this code, it's just basic REST template. This is nothing fancy. I'm just using the REST template that you know and love from core Spring that's been around since 3.0. The REST template is a very, very convenient HTTP client. And here I've just got methods that make RESTful calls into the service, right? Interacting with the resources, interacting with the responses, and so on. So for example, I have here a create customer client-side method. Takes a first name, a last name, and a sign-up date. I create a map. I don't even need to type for this. I can just create a map. Create an HTTP entity, put the map in there, put some headers in there, telling it what kind of content type I'm submitting. And then I use the REST template, and I post the entity to my /customers URI, right? And I get the URI of the location from the response. Remember, we set that up in the headers. And then I pass that to my customer method, which simply goes to a URI and loads the JSON representation of a single customer and creates a local object out of it, a resource of type customer. And I create the unwrapped customer, which simply takes out the customer data from the resource. So this is actually, it looks like that actually. Okay, we don't have time to look at all of the API URLs, but let's actually, there's a couple of things worth looking at here. There's the update profile photo. Remember earlier we had a photo endpoint that you can use to update the photo. That's actually a file, it's a file upload basically. Well, here's the REST template version of that on the client, right? I'm actually taking the bytes and the media type, creating a byte array resource, returning a file name, so I overload that. And then I create a multi-value map, set the file data itself, and then put the byte array in there. And then I use the REST template to post to the endpoint there for my photo endpoint, right? Building up the URL on the client. We have a similar thing here to retrieve the profile photo. We can retrieve it, get the media type and the bytes, and then we return that back to the client. As an aggregate DTO kind of thing called a profile photo. So let's take a look at how to use this quickly. I have a little public static void main example. Like I said earlier, you're probably going to want to use this in terms of some sort of web application, right? So you have one web application displaying data from another one. So here's my application. Context, I'm building up certain properties I need. So I need to know which URI to connect to. I need to know which kind of client I am. I need a security. I need that password, the secret that I specified earlier. And I have two different endpoints. And then I have a client example object that simply does, it's a manually driving the OAuth dance with Spring Social. So here I'm setting up a OAuth2 operations. The OAuth2 operations can be used to make a request to get an authorization URL. And then I open up the browser with that authorization URL, and it prompts me to approve the user in my application. Once it's approved, it'll redirect back to a URL where it'll specify an access token. I manually grab the access token, and then I give it back to the to this little dance here. I give it back to the code to a swing input dialog, and then I use the access token to create my connection, which of course goes into the machinery that we saw earlier. And eventually, I'm given a connection of type CRM operations. I can then use that to get an API implementation, and we can actually work with that implementation down here. So here I'm doing what you would expect. I'm getting the user profile. I'm getting the API implementation itself. I'm actually getting my current logged in user That's this the type from my API as opposed to the Spring Social API. I can actually use it to create customer data here, and then also read the profile photo and store it on the desktop. Right, I'm going to store it as profile. So let's go ahead and run this thing. We'll see it all in action. Okay. Okay, so it prompted me to log in and approve it. Do you want to approve the Android CRM with the following permissions? Absolutely, yes I do. It redirected. It doesn't matter where it redirects to. If you're in an Android environment, for example, you might use a web view and you can trap redirect URLs. Obviously, the web application can't redirect to my public static void main. That's why you want to you need to trap it somewhere. It doesn't matter where though. So I'm going to grab the access token there. Go back to my little Swing application here. And by the way, so we're on the same page here. I have lots of things on my desktop, but what I don't have is a profile.photo. You recall earlier that we uploaded this guy. We uploaded that as my profile photo. So I'm going to take that URI, take that access token, plug it into this, and then back to the editor, and we can actually see it sort of churning along here. And it's already finished. I created a GET request for the user, and then I started working with the client. I started navigating the information. I wanted to get the current user. That's this request here. I wanted to add things to the customer record collection. So there I'm doing that as well. Wrote the JSON record, etc. And here I'm actually going to the photo endpoint, making a GET request from the photo endpoint, and I download the information as image JPEG, and I save it to the desktop. So if you go over here, you see a profile photo. Same as this one, the one we uploaded, right? It's the same one we just uploaded, but now it's going to a secured channel. Okay, so that's about the end of that. There's a lot there. We looked at sort of how you might evolve the system. There's a lot to be talked about here, of course. If you want to learn if you want a really good sort of nitty-gritty introduction to REST, there's nothing better than the source material from Roy Fielding's doctoral dissertation. Earlier on, I showed you the Spring REST shell, which is a nice way to interact with RESTful hypermedia-aware services. Of course, if you're looking for code, don't hesitate to check out github.com/spring source. Oliver Gierk gave just a walking, amazing talk from RIDev last year on building hypermedia applications with Spring Head OS, so definitely check that out. Les Hazelwood from Stormpath has done a lot of work, great work on, and some great talks on building beautiful JSON REST APIs. I encourage you to check that out. And our very own Ben Hale has also done an amazing talk, a video of which is available from Spring1 from last year on our YouTube channel at Spring Source Dev. As for me, you can get the code for this under github.com/Josh Long, and slides are there as well. And of course, if you have questions, now would be the time to ask them. And by the way, don't hesitate to reach out to me on Twitter at StarbucksMan, and my email is josh.long@springsource.com. I think we're going to go back to the webinar now. Let's see.
Hey, Josh. Yeah.
Yeah.
So Craig has been pretty diligent in answering questions. There's a couple left over, not many actually. He's pretty much got them all, and we are pretty far over time. But
I know. I'm sorry. It started late.
No. That's not your fault at all, my friend. Yeah, we had a little WebEx trouble this morning. It looks like actually a large amount of the audience has stayed on the phone, so let's keep going for a few more minutes. Joseph Alex asks, when is the Spring Data Repository useful? He didn't quite catch your explanation on it fully.
So Spring Data Repositories it's a generic repository implementation. The idea is that there's a lot of basic procedural sort of stuff that you have to do to work with data access stores like JPA or MongoDB. Spring Data itself can do a lot of that for you based entirely on convention. So if I want to create a repository that simply injects a JPA entity manager, and I want to expose a method to find, to look up a record, I might create a find user by first name and last name. Well, I know what that's going to look like. In my head, I know that when I create a repository implementation that I'm going to later then inject into the service tier, that repository will simply take the entity manager, create a query of the form select all from user where first name equals question mark and last name equals question mark, and then return me the user data from the JPA entity manager. Well, that's so procedural and so predictable. And it's similarly predictable if you try and do it from MongoDB. We can you can all but write the code in your head what that's going to look like for MongoDB, right? There's nothing fancy about it. So what Spring Data repositories do is, based on the name of the methods, it gives you the query. It actually creates an implementation at runtime that satisfies the query, right? So if I have a method called find user by first name and last name in an interface, Spring Data will automatically create an implementation class at runtime that implements that interface that automatically provides the methods that support that, that convention. So it would actually dynamically write the JPA query for you to select all from the user where first name equals question mark and last name equals question mark. If you have a Spring Data repository of that form, you can then annotate it with @REST resource, which is a Spring Data REST annotation, and that annotation tells the, it tells the Spring Data REST to export that repository and make it available, so that if I want to manage users in my user repository, that maps to a user's endpoint in my REST topology, my REST URL topology. Does that help?
Yeah, he said great a couple times. And he went on to mention that usually he has a DAO layer that deals with all the data access, and was curious if that's more REST friendly.
Well, so the DAO layer, that's exactly what the repositories get rid of. You don't need the DAO layer, because often that's just procedural code that, you can close your eyes. That stuff is just, it's monkey work. You don't need to do it, You might have business logic, actual business logic at the service tier, but writing these queries and querying the database based on these very, very common conventions is, let the machine do it. Let the repositories do it for you. So think of Spring Data repositories as DAO++. It's the next generation. It's the way to, so you don't ever have to write a repository or a DAO. It's the same thing, basically, ever again.
Antonio Avestado asks, hey, we want to put Spring integration on top of the services for URL-based redirection. Could Josh's approach be valid for us, or would a lot of changes be needed?
I'm not trying to, so we want to put Spring integration, which I love and have contributed a lot to, so I'm a fan, on top of what? Again, say it again.
On top of the services for URL-based redirection. Note that this question comes from about 8 a.m., so this was a little bit, or back up a little bit mentally in your talk. Yeah.
I don't really understand. So
yeah, I was having trouble with that one too. Antonio, if you're still on and you want to clarify a little bit, please feel free.
And I have my email. That's my email, guys. I mean it. If you have questions at all, if you have any questions, don't hesitate to reach out to me. It's my job. I love talking to you guys.
Cool. Okay. Let's see. I think. This is a good one. What's the difference between, and let's keep this one short, Josh, but what's the difference between SOAP-based and WSDL-based and REST services?
So SOAP is it's what we refer to as POX. It's basically a RPC mechanism channeled through HTTP. The fact that it's using HTTP is almost incidental, which is why SOAP can actually be used over JMS or other transports. It doesn't embrace HTTP. It basically lets you pretend that you have objects that have methods, and you happen to be using HTTP as a way of having that object method invocation thing. In that world, you have something called WSDL. WSDL is a way of specifying a contract. It's a way of defining the schema for the SOAP service. In the REST world, you need something, in the REST world, you're not doing POX, you're not doing SOAP, you're not doing RPC, you're doing more like messaging, right? You're sending messages back and forth. These are commands, if you will. These are not RPC calls invoking methods on objects. And if you want the equivalent of WSDL, there's a couple of things in the REST world, some of them better than others. One convention is called WADL, W-A-D-L. It's not a standard, but it is sort of a common going concern. You can also do something. You can also, the Spring Data REST stuff that I just showed you guys actually gives you a schema object. This is not a standard convention or a standard representation by any means, but it can be convenient if you want a way for clients to, grok the layout of your application while they're learning it, right? So let's see, I'm going to open up all those. So here's an example of the schema. If you go to the endpoint there for customers, right? It's a single customer, gives you the URL, gives you the URL to the actual self itself, the user itself, gives you the name of the type on the job side, which frankly, it's kind of a leak. You shouldn't send that back to clients anyway. And then properties, and it gives you the types. This is not, you don't want this, right? This is not something you should rely on, but it is helpful if you're learning an API. It's like a very enhanced Java doc. It is not a client contract. It is not to be used in the same way as you might WSDL. And the reason is because fundamentally your contract is HTTP. You have certain types of payloads with certain properties in them, and then you have verbs, and that's your API. You don't want methods and parameters and all that stuff, really. I hope that helps.
Yeah, sorry, I got on mute there for a second. Okay, so then let's see. Interesting question from Bassam. Multi-clients like JSON, XML, and HTML. How do you handle all of those in a portlet environment?
Huh. You mean consuming, or you mean delivering a JSON and XML and so on to be consumed from a portlet environment? I assume it has. I assume it has nothing to do. I mean, there's nothing endemic to portlets that would preclude you from using REST. Spring MVC works in a portlet environment, and there's no reason you couldn't stand up the REST support there, I would imagine. Portlets themselves are a server-side construct. REST is very much a client-side.
Yeah, I'm guessing he means consume, but Bassam, if you're still Zodi, if you're still on, feel free to clarify in the chat with
email or chat with
or email, yeah. Let's see, another question from, oh, it looks like Craig's getting that one, actually.
So, Craig, thank you, Craig Walls. And big thanks to Craig Walls and to, especially thanks to Craig Walls, but also to Rostin Stoyanchev and Aryan Putzman and Oliver Gierk, who all kind of gave me a lot of guidance as we were preparing for this talk. They're the ninjas on the stuff. They created it, they wrote it, they're the experts. I appreciate it very much.
Let's see, another question from, I'm probably going to not say his name right, so I'm going to truncate it and say Venkat. How do you handle when the IDs are large in a list get operation?
How do you handle when the IDs are large in a list get operation? So like in HTTP get users /1, 2, 3?
I believe he didn't say anything more than that.
Well, so we have something we introduced inside of Spring 3.2. We introduced the support for path segments. This is an HTTP convention. You can specify common and limited lists. Or, I'm sorry, matrix variables. These are called matrix variables instead of 3.2. You can say HTTP get, users /, and then you can tell Spring MVC that the segment, 1, 2, 3, 4, whatever, or 1 semicolon 2 semicolon 3 semicolon. That's a matrix variable, and you can actually have Spring MVC give that to you as part of as a matrix variable, as a map of longs, or a map of objects rather, or an array of longs. But so that's one way of handling batch gets. I wouldn't do that if I could avoid it, but if you need it, that's there. In terms of like specifying a large list of IDs.
Yeah, he's saying he has like 100 IDs.
As long as it fits within HTTP, so there's a certain size to URLs. It's like a couple kilobytes, I think. So as long as it fits within that, you should be okay. If you really need something bigger, you could, in theory, do something very non-RESTful, like a post that has the IDs in it, or some way of conveying the data that isn't subject to the limitations of the URL length, and then return the response. But that doesn't feel very RESTful to me. Craig, what do you think about that?
He's on mute. He's got a noisy background, so we can let him comment on chat for this, I think.
Sure.
There's a couple of other questions, but if you want to polish this one off.
Oh, no, I'll take, as long as we got time and they're not bored, I'm happy to answer anything, but it's all you.
Well, we still got almost 130.
You say that again?
Let's move on. We still got almost 130 participants on the line. Let's move on first with more questions.
Okay.
Let's see. Yeah, earlier I was asking about REST and in a portlet environment. He was talking about the WSRP remote portlet protocol, and he was wondering if REST can replace SOAP with that WSRP standard. I'm guessing no, but
well, I don't know much about WSRP, but REST can always replace SOAP. You can always. It's not the same, obviously. It's not a one-to-one, but I find the trouble of introducing a REST API is you're rewarded with increased simplicity. You know.
WSRP is something very specific to portlets
Right.
and remote. So I don't know. I would imagine that we actually have to make allowance.
Yeah.
But anyway, you know, if you weren't doing a WSRP portlet, maybe you could. Let's see. Oh, okay. Here's another good question from Nelson. Given that we should use the status codes from the HTTP standard, if a user attempts to access a resource that doesn't exist, how do we distinguish between a 404 caused by a non-existent resource and one caused by an unreachable host?
Good question. I don't know, actually. Yeah.
Yeah, that is a stumper, isn't it?
A little bit. Is that what you get back if your host is that? I don't even know.
If you can't get it, so you get you.
In practice, what difference does it make? That's I suppose the most important question. If it's not found, that is a generic way of representing the URL. The problem. You can use a more specific status code if you think that the client made an error. So you could send back a client-specific status code telling the client that he or she should retry. Whereas the 404 signals just that. It just signals that the page isn't there. That doesn't necessarily imply anything to the client. So you might do something more specific, like an error code, you know, in one of the other numbers.
Those are a good one, and I think leads to some of what you were talking earlier about hypermedia. Joseph Alex asks, any best practices or patterns for REST versioning, e.g., you know, how do you maintain multiple versions of the API?
So, you know, actually I had a little section on that in this talk, and I wanted to include it, but as you know, it's long enough without it. Versioning, there's two different types of versioning. There's service versioning, which is typically what you see when you see URLs, it's like v1, v2 in the URL, and then you have data versioning. Data versioning you can handle with something called a media type, right? When you ask the client, when you ask the server for data, you might ask for a specific media type that can have a version. So it looks like you know, it might look like, you know, for bar v1, you know, v1, whatever. You can do that kind of thing, right? Or v equals 1. Like that, and that's actually a media type that you can send when you specify the request itself as a header. You can create your own media types, right? There's no problem at all. It's actually like X plus fruit. There you go. So that's one way to solve it, and then the server can optionally return the data that you want back from the service. Again, it's, you know, and if you don't specify a type, you can leave that part off. It's just a parameter, then you get the actual just the latest and greatest representation. That's data versioning. It's up to you to handle that in your own specific way, so you can actually sculpt through the headers and return the right version. If you're using service versioning, again, this is where it's very nice to use hypermedia because you're now abstracted away from the fragility of the URLs. If you decide to release v1, you know, users 21 right now, and then tomorrow you introduce v2 users, as long as the clients aren't caching the URL, they won't break. Nothing will change. This will still be the link rel for user, right? It'll be user today and it'll be user yesterday. It's the same link rel. The URL has changed, but you're immune to that in the client. So that's another benefit of hypermedia, right? You're no longer tied to these fragile URLs that may or may not change.
Okay. Any particular benefit of using the @inject over @autowired? This question comes from Yashpal.
There's slight nuance differences, but no, they're both natively supported by Spring. AutoWired is, of course, the Spring proprietary sort of original one. AutoWired has a lot more functionality. I just tend to use @inject just because it's a few characters less and it achieves what I need for the most part. But no, not really. If you have JSR 330, on the class path, and you use that, it'll work just fine. It works exactly like @inject, and in fact, we have support for JSR 250, which is the JavaX.resource annotation. So all three of them achieve basically the same effect in that particular case. But no, not really. We try to support annotations where possible.
Vikas Badwar is still on the line, I'm noticing, and he has one unanswered question. How do we manage transactions in REST? This is a good one. How are new transactions started, and what about if the REST transactions roll back, blah, blah, blah?
So this is a very common question. Obviously, the sort of flippant but not very helpful answer is don't do it. And the practical approach is what I tell people is there's no correlation between data types and the messages that you send to a RESTful endpoint. So in this case, I have been sending payloads that map to customers and to users, and that happens to map very nicely to our Hibernate API, which is customers and users. But that's not required. I could have an endpoint that takes a profile update object, and that profile update object can update both my customers and my users in one payload. So if I take that, if I make one HTTP request against that RESTful endpoint and it transmits everything I need to mutate on both customers and users in my Hibernate graph, I can put that all behind one transaction, right? I can unwrap the requests and then propagate that to my service tier. And my service tier, of course, is going to have resource local transactions. That way I don't need to do XA or anything like that. I know people are, I expect that the question he's really asking is there such a thing as WS transactions for REST? No, and from a pragmatic point of view, I hope there isn't going to be such a thing. It would complicate it, right? Just send the changes you need as one HTTP request, and then update it that way. If you really need to do things like compensatory, you can do things like compensatory transactions where you have you keep the state on the client. If something happens on the RESTful call, then you can just retransmit the original state. That's fine. But there's not really a great way to do cross HTTP XA types transactions. Like I said, I would do whatever I could to make one request to the service, and then have all the changes happen inside of one local resource transaction behind, in my service tier using @transactional.
Yeah. Vikas is saying he's using like distributed transactions like JMS and then REST.
Well, so that has, okay, so as long as that's all hidden behind your service tier, Spring doesn't care, right? I mean, you can use a Spring service. So JTA was Spring. There's a blog I wrote a couple years ago. It's called Glenn's birthday. So there's a blog I wrote a couple years ago called Configuring Spring and JTA without full Java EE. And this talks about how to use distributed transactions in the back end in the service tier, right? So this is building on top of Spring's @transactional. And the idea here is that you can do resource local transaction management with JTA Transaction Manager or the Rabbit Transaction Manager or the Hibernate or JPA or JMS ones. But if you want to use JTA, which you can use our JTA Transaction Manager, and you can set up a user transaction and a transaction manager from either a full-blown Java EE server, or you can set them up, independently using something like Atomicos, and that can run outside of the container. You don't need a full Java EE container for that to work. You can just use Tomcat, and I set up. There's code that shows how to do that here, and the point is, from your perspective, it's still just going to be one method with @transactional. This @transactional is going to delegate to the JTA Transaction Manager. The JTA Transaction Manager will let you coordinate with whatever resources you've been listed in that transaction, including JMS and JPA and JDBC, etc. But again, so that's a very common case. JTA is very common for JMS and some sort of SQL store. And the example here is exactly that. I have a database and I have JMS. But that isn't REST. That's just that's the service tier, right? So what you want to do is you want to create one method, annotate with @transactional, and that @transactional will delegate to your configured JTA Transaction Manager, and then you call the service tier method from your Spring MVC controller that handles a REST call. So you have one REST call, but it goes to a service tier, and then that's where you do the JTA stuff. There you go.
Got it. We are starting to run short on time because, as you know, we've got the next webinar coming soon, and questions are still coming in. Craig is being a hero and taking down a bunch of them. We still have almost 100 attendees on the line. which is about 60% of, or excuse me, about 40% of what we were at the high water mark. One more question from this guy's been very patient, and it looks like he's still on the line. Just a moment. Lakshman M. From Quatris Technologies. He asks, are multiple GET requests supported simultaneously?
Sure, why not? HTTP,
yeah, I was guessing so. It's like servlets are multi-threaded, right? So.
Yep, totally. Controllers are controllers, and they're not synchronized. There's no serialization. You can make as many requests as you like. If you have a controller, if you have class state in your controller and you're trying to mutate that, obviously that's subject to thread safety. But in most cases, you're just going to inject them in and transact like a service, and then the service is typically thread safe. I mean, typically you don't. It's very hard to write non-thread safe services with Spring, but it is in theory possible. So just make sure you have thread safety in the service here. But if you're using a JPA entity manager or whatever, that's no problem. It's automatically thread safe.
Sunil Deshpande asks, is publishing WADL, W-A-D-L, for a REST service considered a good practice?
See, here's the thing. If you need it, it's out there. To me, it feels like a SOAP-ism. It feels like a way of doing in REST what you used to do in SOAP. If you need it, then of course it's a good practice. If you need it, Spring MVC doesn't have a particular support for it, like I said. Spring Data REST does export that very convenient little schema payload that I showed you guys earlier. That's cool. Yeah, I've heard people using it. I've used it before, WADL, I mean. And in fact, there are client libraries. So there are libraries that automatically generate WADL for you based on annotations on your controllers. And if you read the This Week in Spring roundup that we do every Tuesday, I think about a year and a half ago, I actually published an implementation. I actually published a link to a guy who had created a WADL exporter type thing.
One of the attendees is commenting. He's saying, "But isn't the point of HadioOS to embed the state machine that explains that resource state can be transitioned?"
Exactly. I wouldn't do it. Yeah. Exactly. I wouldn't use. Yeah. That's the whole point. The state machine, the workflow that you're trying to convey is described by Hypermedia, but WADL in particular can be used to describe the payload contract, and that isn't specific to that isn't something that's solved by Hypermedia. But the payload contract should be simple. You should be able to decompose your payload in most cases to keys and values that are sent by HTTP verbs, right? So your API is the combination of keys and values that you require in your request, and the verb it should be sent over, and which URI. That should be your API, and it shouldn't be hard to describe that. That's the whole point. It shouldn't need that much, stuff. And plus, RESTful services are by default very defensive. There's only one way to get it right, and a 1,000 ways to get it wrong. But at least with HTTP, you have inbuilt mechanisms for conveying errors and so on. Like Spring HadioOS supports something called VND errors. VND errors is a payload type that you can return that the programmer can look at. It actually has a human readable message, and it has a status code and all that.
I think this is going to have to be last question, folks. Bassem Zodi asks, how you handle async calls with REST?
So it's very common to, for example, if you have a long-running process in the background, to send a request to a RESTful service, and then instead of returning HTTP 200, or even 201, you return something called HTTP 202, I think, and that means accepted. That signals to the client that the request has been received, but the work that is going to be started as a result of the request is still ongoing in the background. You would also return in this situation a URI as a convention. You would return a URI in the location header back to the client, signaling to the client where the client might check the status of the operation. So, for example, if I'm uploading and processing a spreadsheet or something, or uploading, I'm doing my Instagram thing and I'm uploading a photo, I can upload a photo and then get the response back immediately. And then in the background, that gets processed, and then the client gets a location header where he can check the status. He might go to the photo endpoint, whatever, and if it's there, you'll get if it's there, you'll get HTTP 200. If it's not there, you'll get doesn't exist, and you can check that periodically. In Spring MVC itself, of course, we have Servlet 3 support, which supports asynchronous servlets. So you can actually background controller requests to a thread pool in the background, so you're not monopolizing socket-bound thread pools on the front end that are being managed by the server container. So we have very good support for asynchronous execution in both Spring MVC as well as HTTP.
Okay, I lied. This is the last question, and partially because it's this Sunil guy has asked it a couple times from Thomson Reuters, and it's funny. I ran into some Thomson Reuters guys at EclipseCon, and they seem like really good fit for what we're doing here at Pivotal. I'd love to find that guy's name again. Sunil asks, can we delete multiple users in a single request? And I think he's referring to your source for this demo on GitHub. I think he's asking specifically about what's in your repo.
In my particular thing, I didn't have it set up to do that, but like I said earlier, Spring MVC and HTML, HTTP in general support something called a matrix variable. And so that is basically this guy. So I can say IDs, and with that, I can put that in a controller handler. So void, do, delete, whatever. I have a matrix variable, blah blah blah, and I have at request mapping. Some endpoint, whatever. And you can say that this is a delete method, and it goes to this URL here. Users, whatever, IDs, right? So that that'll be converted into a matrix variable, and the way you would specify that request is it's going to look like this. It'll say users 1, 2, like that, semicolons, right? That's a matrix variable, and that'll all get extracted out for you. For more on that, I would definitely check out Ross and Soranchev's blog, Matrix Variables, Spring MVC. No, I guess, oops. We don't want that one, we want this one here. Matrix variables. Check this out. This is the right way to specify a list of IDs. It's very, very powerful. Thanks for it. There you go. See, so matrix variable in Q could be used to extract a single ID if you needed it, or it can be used to extract a collection if you want. What is that example? Here, there you go. With matrix variable, string, matrix bars, and so that way, if somebody sends me pets 21, q equals 22, s equals 23, I can get all those variables there. I can also extract them out into just numbers, in consecutive.
All in a single request. Yeah, that's what.
Yeah.
Okay.
Yeah.
All right, folks. Wow. We need a couple minutes to reset for the next webinar. So thank you for all 82 of you that are still on the line. We really appreciate all the questions and interactivity. Please, take Josh up on his offer. Hit him up on Twitter. He's very helpful. As you've now noticed, he stayed almost an hour beyond the webinar time to answer questions. We'll post the replay on springsource.org and on our YouTube channel, which is youtube.com/springsourcedev. If you love us, subscribe. Just subscribe to YouTube, and you'll get like all the replays and all the Spring 1 TGX videos and blah 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 blah. So thank you so much for coming. We're going to reset for the next webinar now, and
thank you guys.
Thanks again to Craig Walls for joining up and being a ninja, answering some questions on the chat panel.
Totally.
We'll see you guys in the next one. Josh, anything else you want to say?
Thank you, everybody. It was great talking to you. I'll look forward to talking to you on email and on Twitter, huh?
Okay. All right. Take care, everybody.
Later.